Today, we're looking at the 737 MAX, specifically the chain of engineering decisions that led to tragedy. So how can a piece of software bring down a brand new plane? Well, the problem wasn't originally digital. It all kicked off with a simple business need, making the 737 more fuel efficient to compete. But the bigger, better engines wouldn't fit, so they had to be moved higher and further forward. And that new placement created a huge aerodynamic issue. The plane's nose had a tendency to pitch up. Now, instead of a costly physical redesign, engineers decided on a software fix to solve it. That fix was called MCAS. It was designed to work in the background, completely automatically. But this software solution, as clever as it seemed, had a catastrophic design flaw baked right in. MCAS relied on data from just one angle of attack sensor, even though the plane had two. This created a single point of failure, a huge no-no for any flight-critical system like this one. On top of that, the system was given way too much power, enough to completely override the pilots. So you had pilots fighting a system they didn't even know existed. Why? It wasn't in the manual. The safety analysis was just based on flawed assumptions about how pilots would react in a real crisis. So you see the sequence? One bad sensor kicked off this entire tragic chain of events. And twice, on two separate flights, this exact engineering failure played out, leading to absolute tragedy. So, what are the big lessons here? This story is a chilling case study in engineering and safety. A few key takeaways: redundancy isn't optional, and transparency for the person in control is absolutely critical. It really makes you wonder, doesn't it? When does a clever software fix become the most dangerous problem of all?